Hi everyone, welcome back. So I have mentioned previously that I would talk about each attribute individually, and I have also had a query about how to demonstrate the different levels of signing off each attribute on the online system. So a little bit about that. If you're with an IC accredited training scheme, you can upload the evidence that works towards your chartership application to a portal. It will be signed off by your DE, your delegate engineer, your SCE, or a mentor. You can sign each attribute off at different levels. So in ascending order, they are knowledge, experience, ability at IEng, and ability at CEng. What I'm going to talk about today is that upper tier, so the chartership level at CEng. And the hope is that if you shoot for the moon, then you should be able to get all of it. Or if there are any gaps, you can talk to your mentor or DE about it and see what part of the attribute is missing for them so that you can get it signed off completely. The reason why I go for this approach is because the boundaries between experience and ability, specifically for me, I find it quite hard to define. But anyway, let's get straight into attribute 1, and of course, subscribe and comment if you're interested in more videos like this. Okay, so attribute 1 is understanding and practical application of engineering. And for those of you who've been around a long time, you'll know this used to be 2 separate attributes. The understanding bit and the practical application bit were separated. And it was quite difficult sometimes to know the difference between one and the other. But this is basically the bit of your chartership application where you demonstrate, regardless of what discipline you're in, designer, contractor, project manager, sustainability consultant, that you understand the theory of the bit of engineering that applies to your work, and you understand how it gets delivered, even if you're not the one delivering it yourself. So you can find all the sub pieces of information of this attribute on the IC website, and you've probably already read this. And what I find is that a lot of these bullet points overlap, and it's a lot of text. So I see this attribute in 4 words, which are theoretical approach, improvement, judgment, and technology. And I'll just go over my definitions of each of these things. So theoretical approach is about understanding what this task has to be done in accordance with. So it could be the highways regulation, the bespoke third-party requirements, or design standards local to where your project is. And these are important because they're about the boundary around what you can do, and they're also what your work is going to be checked against. So this is about what your system or design has to satisfy. Improvement is about seeing if there are any better techniques or ways to get this done. In our companies, we're always looking for efficiency. So sometimes we will use an existing process in a new way. That's also a form of improvement. Or we are trying to make something compatible or try out a new software that maybe your company has not used before. Now, if that's the case, you can make an argument about whether that software was good or bad. That's the evaluative portion of the attribute. But also, if you're involved in bringing something new to the way that your company works, you have an opportunity to provide training on that. So that's also part of attribute 7. And I think that's a good thing to talk about if you ever have the opportunity. Judgment is then about understanding what are the limits of the things that you can do and what you need other people to help you with. So when you're in charge of some part of a project, you're likely interfacing with lots of different specialists, so you need information and guidance from them. And the important thing to understand here is, how do you satisfy yourself that the information that they're giving you is correct? Are you aware of the codes that they're working on and what their deliverables are? And technology is the final one, and I would say to some degree that everyone uses technology to do almost everything now because of we work in more of a digital system. There are multiple technology options to do any given thing, and it's just worth understanding what advantage the use of technology gives you, what it enables you to do, and also maybe what you would like it to do, or what functionality of it you're not using and maybe would like to. Also, sometimes technology gives you the wrong output. Are you confident enough in the theory to be able to diagnose when something like that has happened? So one example I gave of this attribute when I was writing my chartership report was that we were using a clash detection system as part of our building information management package. And it was really good at seeing when two things were clashing with each other. So, for example, when structure was clashing with a pipe or something. And what we were trying to get it to do was tell us when structure was clashing with headroom in a car park, for example. So the method that we were trialing was to model the headroom as a separate block so that it would be a thing, because there was no way of like setting a parameter to say this needs to be the headroom. So the architect would model the headroom as like a physical block, and then the pipes or structure, if it was interacting inside that block, it would tell us, okay, your structure needs to be thinner because it's interacting with the, allowable headroom. Okay, so one way of understanding what that higher level of CEng is to be able to separate it from the IEng level. So a common theme between these points that you can see in orange is more about your position in relation to the activity. So it's more about being actively involved in setting the task parameters or choosing the methodology behind it. And what this demonstrates really is that you've done tasks like this before, you've probably done it multiple times, and you have experience enough that someone would trust you in giving a task like this, and you can manage it for the most part. So the next slide will be about how I look at communicating that I did a task at CEng level. So if you think of a typical task, you would say, okay, so someone sets the task, you find the code or the theory that applies, you conduct the calculations, and then you communicate the output. But at CEng level, it's more like you need to choose the solution. You need to choose the engineering solution that solves a particular problem. So for example, if you have an asset, what's the methodology by which you decide whether you're going to replace or maintain that asset, or you're just going to demolish it and rebuild it completely? Or for example, if you have an area where you are changing the ground levels and you need to retain some soil, what type of retaining structure are you going to use? And then after that, you conduct the process and the calculations. Could any other considerations be made that would make this more efficient? So for example, do you want to use the same design across the entire, length of the retained height? Do you want to change the solution where the retained height is different? How do you choose, to make this process more efficient or even more buildable? And then you also communicate the output, and it's usually a drawing. Have you considered how you communicate the risks around building that? How you communicate the sequencing, if that's sensitive to what's being built? Could you do this in a clearer way? So it's about being really involved in setting the parameters for the system, but also being involved in trying to make that better, clearer, and providing lessons for if you were to do that again the next time. And then what I've done here is expand a little bit more about those ideas in writing to try and hit those points that I was talking about earlier. So the improvement, the judgment, the technology, and the theoretical approach. So I would start, if you were writing this out in a narrative, by talking about what your approach to the task is. Obviously name the standards that you are using, and it really helps to demonstrate all of this if you've done something that is particularly complex or something that requires a lot of information being pieced together in a unique way that someone else hasn't done before. And then of course, what techniques did you choose? Have you learned anything from previous techniques? And that's demonstrating really your experience here. And then also thinking about multidisciplinary teams. So for example, if I'm a structural engineer, I'm designing a retaining structure, I need soil parameters, and I need to speak to a geotechnical engineer about that. I know that I can't derive those myself, right? So it's about those people that you are working with and being able to understand, okay, this is the process that they use to get to this answer. And then evaluating what went well and what you would change for next time. And this happens on most projects. We just don't necessarily think to write it down. Not everything goes entirely well, whether that is your the type of design that you chose, or it's like the system by which you communicated that. Any of these things can be improved, and it does not make you a bad engineer to have lessons learned for next time. And what does help is that alongside this, you also submit a drawing, which is the final piece of what you've done. It's the culmination of all of those ideas together, all of that work, all of those points in the attribute. And of course, it should ideally have your initials on there, or some indication that it is your work and that you're not presenting someone else's work in this way. So I hope that that was helpful. Please let me know what you think in the comments, and I'll see you in attribute 2. Bye.